Hello everyone, I'm Johannes Brummer. This is my first presentation ever, so let's see how it goes. I'm a pulp and paper engineer, dropout, an electrical engineer nowadays, who just ended up in IT sector because all the pulp mills went down in 2009. I've done this for some years. Nowadays I'm working at Verda, formerly DataCrunch. And their beef is basically GPUs. I'm not going to read the slides. Everyone can read themselves. But here are some topics. GPUs are nowadays pretty bleeding edge. We don't have any software and hardware support. Or if we do, we have some vendor patches that aren't yet upstreamed. Then there's going to be some rant about vendors, how to install them, as in the physical hardware. Anyone who has worked in bleeding edge network devices knows the pain. And then there's always the customers and what they're expecting. So what is a GPU? Graphics Processing Unit. Originally, idea was just to throw pixels at a screen. Then someone invented, hey, let's do some gaming cards. So we have to do this faster. At the cost of accuracy, of course, because no one cared if memory was a bit broken, so a single pixel wouldn't light up in a certain correct color. It didn't matter at the time, but nowadays everything crashes. The industry decided that let's do some workarounds. Floating point numbers are hard for GPUs, so let's shorten them up. Instead of 32 bits, let's use 16 bits and 8 bits, and nowadays the latest AI models are quantified in 4-bit accuracy. It's fast enough and good enough. ECC memory helps a lot, and there's a lot of it. It's nowadays 3-dimensional memory. I'm not going to go through that. Then there are certain optimization instructions that are below the CUDA and ROCm level that are normally used to program the GPUs nowadays. The data center GPU isn't actually a GPU because it doesn't have any display connectors. The board area has been used for something else, for more memory and so on. So it's more like general purpose or general purpose accelerator, more or less. So the first iteration was just, let's take a GPU and plug it into a chassis. Let's pass it through to a VM. There are a certain number of slots we can use, and let's see how it works. Then the whatever coin, everyone knows, time came, and then there was these open chassis things, so that you can plug multiple GPUs. You can split the 16x line into 16x1 lines and attach 16 GPUs into desktop hardware and run out of power in multiple ways. Then someone wanted to install those into a data center. You can do it on a shelf or use an actual hardware to do it, like in server-grade hardware that has remote management and all the things you want from a server. The examples here are Dell servers because I've used them earlier. The 13th gen Dell had the basic Molex connector that everyone who has ever installed a GPU knows. It's the one that plugs into a GPU, at least did some years ago. Then the newer ones had a separate GPU enablement kit. And nowadays it's just a tray of GPUs that are tightened into a board, and then that board is installed into a server chassis. Then it's connected physically. Let's go to the firmware side. Usually this is the place where all the trouble begins. At the first iteration of server hardware, when you plug in a GPU, it will override, as in you don't have the remote console anymore because the display output switches to the GPU. So you can't see what you're doing unless you move the display into the GPU that you just installed. That's solved. Then it might not see all the cards. It depends where it's connected, how it's built, how it's grouped, where's the root bridges, and if there's any PCI switches in there, where are all the devices installed. Then it's also nice to get some error reporting out. That's the PCI AR ear, and ACS. It's basically a software signaling that, hey, something went wrong here. Let's not crash and try to handle it sanely. And when all this has been done on a minor BIOS patch, all the device paths might change. So just rebooting, installing firmware updates, and everything breaks. But that's pretty common thing also with network devices. Years. Currently, I install Ubuntu 24.04, and I use VFIO stack because it's the de facto standard, basically. Then pretty new kernel is pretty much a requirement. In 6.10, the basic VFIO initialization sped up quite a lot, and in around 6.15, the Blackwell architecture, not the latest NVIDIA, but the one before, got some nice speed-ups so that the VM would start in less than a minute instead of waiting for 3 minutes. Because customers also expect fast boot up times. If you're using the basic consumer GPUs, usually it has the audio output that's split into the HDMI output. If that's passed through, you have to pass through the audio also, because it's basically the same device, even though it's shown as a different one. There are some tools that you can hide, used to hide the audio side altogether. They might work or might not, so it's usually easier just to pass through the audio device, and then customer wonders, what is this sound card that I just received? Then if there's multiple GPUs, they usually want to talk with each other. And that's where this NVIDIA Fabric Manager comes in. It's from the NVIDIA best practice docs to use a separate VM. It's as a service VM that handles every interaction inside the server. Or just run it on the hypervisor level. It usually works on both. But the best practice is the service VM. And NVLink, it's like the SLI bridge between GPUs, even though it's either the actual bridge, as used earlier, probably from the 3DFX Voodoo era. NVIDIA bought them. They probably used the same technology later. But nowadays it's over either separate traces or over PCIe. And it's managed through an integrated InfiniBand card. It's a usually CX7 level card that is displayed on the OS, but you can't actually do anything with it except through the Fabric Manager. And depending on the GPU generation, you might have to expose the actual management InfiniBand card to the VM or not. That's something you just have to test before going to production. At first, it might seem, okay, everything is working nicely. Then after a reboot, okay, it doesn't work anymore. And customers want everything. Everything should work out of the box. It should be the latest version. Everything should be tested. And I just dropped something here, so it should just work. Oh, I made a mistake, so please fix it for me. But we don't have access because it's a confidential compute VM with encrypted disk. Solutions. Define what you're actually offering instead of, let's give this under the counter because you're the good guy. Have an internal team dog fooding everything so that we know before the customer that something is broken or something that actually works, how to configure something, so that when customer comes in, asks from the customer support, hey, I have this thing, how do I do it? There might also already be an answer like, hey, try this. And just the basic balance of being AS and SaaS company. If you're doing IaaS, you're not usually doing SaaS, but it's not always so easy. Then there's this vGPU, as in how to split a GPU into multiple pieces. I'm not going to go through that a lot, because that would take maybe another 30 minutes. But this is the basic setup. It's usually MIG. And NVIDIA requires licensing for it. The way we've done it is, here's a GPU, do what you want, ensure that you have the license to do what you're planning to do, instead of going through the licensing hell. Licensing hell is only like 5 pages in a PDF, but I don't like going through that. So a customer deploys something, then customer shuts the VM down and goes away. What to do after that? It's like sanitizing a disk after a customer has left. But it's not so straightforward because it might not actually sanitize the GPU. The memory might not be overwritten. It might fail the PCIe reset, as in say to the GPU, please reset yourself. And the reply would be, okay, it doesn't respond to anything. It requires a power cycle. Or the customer might have enabled the MIG. So when the GPU comes back, it's actually 7 GPUs. You have to sanitize that and reset the card and hope it survives the function level reset. That's the NVRAM. You change the setting in the NVRAM. And there's some customers that want certain firmwares and then they install them and something goes wrong. But nowadays, they are not publicly available and you can't dump a firmware and install it to a second GPU. It's usually blocked on the BMC level, as in the server says, no, you can't do that. And when you're installing GPUs, they are power hungry. The latest Vera Rubin racks take almost 200 kilowatts. That's a lot in a rack. In a DC that is designed for 10 kilowatts per rack. So basically that's just liquid cooled rack requiring a separate cooling unit. That's heat exchanger between the rack and the data center provider. Then the rail alignment. There's a PCIe switch inside the server. There should be a ConnectX card and a GPU next to each other on the same PCIe switch so that it can talk to a second GPU in a second server chassis straight without going through all the CPU memory, whatever, so that you get the best performance. And those should be aligned, as in InfiniBand card 1 is connected to GPU 1 on both servers, and there's a cable in between, or a switch in between, but anyways. Then there's driver level issues. Here's 2000 code again, someone made an uptime bug. NVIDIA SMI is a command that shows all the information about the GPU. And it just hangs after about 66.5 days of uptime. That happens to be some number 2.2 times 32, 2 to the power of 32 or something like that. And update to this, it's not unresolved, it's resolved nowadays with a firmware update that we haven't gotten yet. Then there's some completely random workarounds. GPU falls off a bus, as in it resets itself but doesn't come back unless there's a modeset disabled, because it interacts somewhat. Then on the Kubernetes side, we found that on that side. Certain driver updates just crashed all the GPUs instead of a single one. So it basically prevented the GPU driver updates. Repository, it exists, it's a good thing. It conflicts with your Ubuntu repository. We get broken hardware. It's nice to find out after burning, in the middle of burning, that someone forgot to torque the GPUs. It's hanging loosely there. And the heat exchanger that is required for the whatever €1,000,000 rack contains a glove in a pipe. That's nowadays that mess of fibers inside the cooling unit. So, easy way, keep it simple. Know what you're doing. Follow the best practice, unless you know what you're doing. Test and test, because big lab is nice, but customers are somewhat grumpy, and everything fails. The hardware fails, software fails. Buy 10% extra hardware just because 10% is usually dead on arrival, and you have to wait for the replacement to come. Thank you.
Thank you very much. Are there any questions from the audience?
I'll leave the best question to you. But do you, when you are in your offering, do you accept 2 different tenants using different GPUs on the same server, or do
Yes.
you? Yes. And is that fun?
Yeah.
Okay, good.
because it's separated by the KVM. It's basic virtualization.
Yeah. So you haven't run into any weird issues where something would bypass sort of the KVM security measures?
That's why we install updates.
Right.
There's always some exploits that you theoretically could use to bypass the KVM level, but you have to keep it updated.
Yeah. Then you said that it's important to eat your own dog food. How do you design the scripts or processes to do that testing?
We have an internal AI team that actually installs all the models and uses K8s and uses the platform as like the customer would use.
So you have a bunch of like test cases like coin mining and whatever.
We don't allow coin mining,
All right.
but yes.
Cool. That was my questions.
And yes, I'll be attending.
All right, good. That's one question. Before you run away, can you name the biggest use case for this? So what are the customers demanding? Why are they using the GPUs? Is that LLMs or not Bitcoin? I get that.
Let's see public references. FreePic. It's image generation platform, and usually it's LLMs.
Fair enough. Thank you. Thank you very much.